Hello, everyone. Thank you for taking the time to join our webinar today. My name is Hugh Peterson. I'm a product manager for Standard Imaging, covering the DoseView water phantoms, both the 3D water phantom and the 1D, which I'll kind of touch on today. And just a little bit of information. This is by no means a deep dive into the DoseView water phantoms. It's kind of an overview. So if you are interested in getting a deeper dive and a more in-depth look at it, feel free to contact either your local representative or your local distributor, depending on where you're located. I'll have emails at the end of the broadcast, the webinar, that you can contact to get more information and maybe set up a more in-depth demo for you. But that being said, let's go ahead and kind of move on with our webinar today. With our DoseView water phantoms and most of our equipment, we know it's an arduous task and time consuming for your demos, or sorry, for your QA. So we try to say, it's your time, be precise. It helps make things quicker and more accurate. Just a bit of housekeeping today. Today's webinar is being recorded, so if you have colleagues that couldn't make it, anybody who has registered for the webinar will get a link to the recording after the fact. If you want to revisit it and kind of take a look at it again, feel free to do so as well. Just because of the number of people on the webinar, we don't, I've got everybody muted, and there's a dialog box for questions, which I will address at the end of the webinar. And as far as standard imaging goes, decided to, because it's been so hot out the last few weeks, to give you a picture of winter in Wisconsin, of our building. We're a very green company. We've got a number of different solar panels for some solar power. We've got a geothermal heating and cooling throughout the building as well. We've won numerous awards for our green functionality of a company as a whole. We're based in Middleton, Wisconsin, which is just outside of Madison. We've got a very good relationship with both the University of Wisconsin Calibration Lab, as well as the Cancer Center at the UW, and also other local cancer centers as well. Founded in 1989. So going on about 34 years now, and originally designed, and our first product off the line was our HDR 1000 well chamber, which I'm sure most of you are probably familiar with for brachytherapy. Along with that, we've got a whole host of other products, from our X-Radon line of ion chambers, and our electrometers, our Max 4000, which has been a workhorse for quite some time, our Supermax, which is our two channel touchscreen electrometer, a number of different phantoms, our Lucy Phantom. We just actually acquired IMT out of New York, so we'll be expanding our line of Lucy Phantoms to include some other somewhat anthropomorphic phantoms as well, for both stereotactic head and also body SBRT. So we've added that to our arsenal, as well as offering a number of different software products, our Adaptivo for patient QA, doing the in vivo component, utilizing the EPID, and a number of different other products as well, our daily device, the Beam Checker Plus, etc. So anyway, they're all designed to make your lives easier in quality assurance in the therapy side of things. But today we're going to talk about our DoseView 3D water phantom, and like I said, I'll also touch on the 1D as well briefly, and then I'll kind of touch on the software, which integrates both the 3D and the 1D functionality. But as far as our 3D Phantom, this is actually our second generation. We designed it originally. It's been about 12 years now, I think. I want to say we introduced our first line of Phantoms, and the second generation came out about 2 years ago, 3 years ago, I want to say. But obviously, your objectives, you want to check your system versus the manufacturer's stated specs for the Linac. You did commissioning of the Linacs, you're checking all your energies, your field sizes, your wedges, etc. You want to do that quickly and easily as possible. And I think with our software and our system, you get very good raw data, and the software makes setup of your scan queues and running those queues very easy. Um, for the water phantom objectives, you've got your annual, your monthly, as well for your TG142, your TG51, your TRS 398, depending on the 3D or the 1D needs for your water phantoms. And then you also have those periodic checks of beam quality. If there's a preventative maintenance or some repair work done on a Linac, obviously a lot of times you need to go back in and do some measuring, make sure everything is still functioning correctly and copacetic with what you've got for your existing data, and your uh, your scan data within the treatment planning system. So it gives you that functionality there as well. As far as things that make a good water phantom that we've kind of really strive for with the builds of our system, which I'll kind of touch on in a minute, you want those highly accurate and repeatable positions and measurements. Obviously, a rigid system that has no flex, has no, any kind of flex that will cause off axis measurement errors, things like that. You want to be able to produce those high quality raw measurements, and with our manufacturing and our rigidity of our system, you get very, very good raw measurements, and that means less post-scan processing. So it's quicker access to getting them into your treatment planning system or getting better results for your annuals. You want reliable hardware that operates year after year. Obviously, best case scenario, you are only using this for your annuals, so you're only pulling it out once a year. That's probably pie in the sky and wishful thinking, I know, but it does, something that a system, like this is not used as often as, say, a daily device or even some of the monthly devices. You want something that's reliable, and when you take it out of storage and fill it and start scanning, you want that reliability. And I think the DoseView 3D has that in spades. You want an easy setup and use. Again, since you're only using it on a best case scenario annual basis, you don't want to have to kind of go in and relearn everything. And the nice thing about our software is its functionality is very straightforward and gives you the ability to kind of quickly relearn it. Off. Without being connected to the hardware, you can actually have a demo mode within the software to play around in it and kind of reacquaint yourself if you're not using it on a regular basis. And then you want that flexibility and compatibility as well. Various detectors, various protocols, be it the AAPM protocols or the IEA protocols, things like that. You want those functionalities in there. You want to be able to bring it into your current treatment planning system. So we've got a number of different treatment planning systems you can import it into. Pretty much everything that's used today is available for import into those treatment planning systems. But getting into the actual our system itself, again, the big strong point is that accurate and consistent positioning. We use five motors, so there's redundancies, and they're calibrated together, so they move in perfect unison together. They're encoded together as far as the larger X and Z positioning goes, whereas the carriage has its own dedicated motor as well for moving the chamber. We use a heavy gauge extruded aluminum frame, which maximizes that rigidity. It simplifies the setup and maintains that reproducibility. Its positional accuracies and repeatability are within the 0.1 millimeter per axis, so it's very, very accurate, very, very repeatable. Allows for a very quick and precise 3-point measurement and leveling. We've got a system that I'll kind of touch on in a minute as far as how the leveling and the chamber positioning works. It's a very unique system. And even before the system goes out the door, every device is tested on an industrial coordinate measurement unit to verify that accuracy and performance from every axis, the X, Y, and Z axis. Every movement of every motor, every position is accounted for within the system itself. And if it doesn't pass, it doesn't go out the door. Some of the items we've got designed for use, the water tank and the frame are secured mechanically together, so it gives you long-term accuracy and integrity. We've got a what we call an advanced suction drain. It's a moat system that helps suck the water out of the as you drain it. So when you get down to the low portion of the water, it actually will keep the armature and the robot system out of the water. So there's no residual, it doesn't sit in any residual water. So there's no calcification, no mineralization or issues like that with the system sitting in water. It drains it almost completely to keep the armature out of the water. And then we've got a fully integrated lift and reservoir cart. It's got a positioning platform that's very precise, and I'll touch on that in the next slide. But basically, you have the reservoir incorporated into the system. It's got a automatic pump system as well for filling the tank, and then rotational locking points on the platform as well, which I'll touch on right here. It's got a once you have the system kind of coarsely adjusted under the gantry under the collimator, you have fine adjustment levers that you can see there in black on the corner and then the two sides to give you fine adjustment up to 6 millimeters to in your X and Y position, as well as rotational as well. And then there's also indents for locking it in at your 90-degree increments as well as 45s for doing your diagonal scans as well. So you can rotate it, you can feel it kind of lock into place as it hits those detents, and will give you the ability to accurately do your diagonal scans as well. The new hardware is lower profile and a more compact design, and that not only improves the rigidity of the system, but it also gives us the ability to be Ethos and Halcyon compatible. It will fit in the bore of the Varian Ethos Halcyon systems, and you can do your measurements and acceptance and commissioning with the Halcyon as well. Another nice feature that we incorporated for Halcyon use is a brass buildup cap that you can utilize for positioning your chamber, and that actually allows you to put it on the chamber and utilize the MV imaging or the KV imaging of the system to localize and accurately position your chambers within the bore of the Halcyon or the Varian system or the Ethos system. Another nice feature of the DoseView 3D system is wireless connectivity, including wireless pendant. And you can see the wireless pendant has full control buttons on the system as well as a digital readout. Gives you very simple setup and system configuration. Nice thing, you can kind of walk your way around the tank when you're checking your levels and doing your runouts to make sure that everything is level and ready to go. You can do that easily without having to drag cords around. It's got the onboard display that shows the probe position at all times. 3 probe speeds, including a 0.1 millimeter step mode. So you've got fast, slow, and step. Another nice feature is a bias switch at the pendant. If you're working in the room and then you go out to the console, then you have to realize you turn the bias on for the electrometer at the console, and then you go back in to do an adjustment and forget to turn the bias off. You don't have to get yourself out of the room again. You can do it right from the pendant. It's a nice little convenience feature. And then we also include with the system the functionality to be either wired to the PC or connected wirelessly with a Zigbee type radio receiver transmitter, so you don't have big cables running from the tank to the wall to the PC. It basically gives you the ability to set up a receiver near the wall of the Linac vault and connect wirelessly to the actual water phantom itself. So a nice feature there. You don't have to be tripping over cables. So that gives you that versatility and convenience. Electrometers, we've got a very long storied history in electrometers. We've been developing and producing electrometers for 30 plus years now, almost since day one. We introduced our Max 4000. We had the Premier 3000 and the CDX 2000B and A before that. So we've got a long history in electrometers, and the electrometer for the DoseView 3D is utilized and kind of builds on that expertise. It's a charge digitizing electrometer for high-speed acquisition, 10 femtocoulomb resolution, so it's a very fine resolution. You have dual polarity bias voltages, so you can choose all your reasonable and necessary bias voltages, either in a positive or negative voltage, as you see fit, depending on your detectors. And there's an independent bias voltage as well, so you have the ability to turn on the bias for the reference if you want, or not use a reference, or if you're using a diode, obviously. For field in a chamber for reference, you can turn the bias on for the reference and not have it on for the field detector. There's built-in into the software safety features too for use with a diode. If you're using a diode and have a diode selected, it will not let you turn on the bias, so you don't have to worry about damaging the diode or damaging the front end of the electrometer. So it's a very fail-safe system too there as well. I've got some of the other time-saving features, is a very innovative and versatile detector alignment system. We do have, it is a manual leveling system. We've looked at, some of the other self-leveling, if you will, systems out there. And quite honestly, talking with a lot of physicists and a lot of users of our tank who have had experience with some of the automatic leveling systems, it's only as good as the system does itself. And any physicist worth his salt or her salt is going to go and check their runouts and do a manual check anyway. So doing it with our system, we've got a very unique leveling system for an alignment system. It's really no quicker or slower actually than doing it automatically, because you don't have to you're doing it as you go. You don't have to rely on the system and then check it, and then if that doesn't work, you got to go through the whole process again. With our system, we utilize a water surface alignment jig, which you can see kind of in the cartoon drawing, kind of showing you how easy it is to visualize the position of the chamber with that on the actual chamber carriage. And as you kind of move it along for your leveling and for your runouts, you can fine adjust it accordingly, and it ends up being very quick. So once you do have the chamber alignment jig in the right spot, we also have this chamber alignment jig here, where you take your chamber holder, you put the chamber in it, line it up with the included buildup cap, showing you the line for the center of the chamber collecting volume. Take that, replace that on the carriage, and it puts the chamber right in the exact spot of the chamber surface alignment jig found. So it's it's a very fast, precise setup. We've got included multiple detectors. You can see there a whole host of detectors. We've got them for our A28, which is our scanning chamber. We've got them for our micro chambers. We've got a universal thimble chamber, which will hold just about any farmer chamber and smaller from there, and then a whole host of parallel plate chambers as well, holders. So again, that intuitive water level alignment jig, as I mentioned. We've got a nice feature too, is an automatically fine beam center. So once you have everything centered and aligned, you can run this fine beam center at either at surface or at multiple depths, and it will give you basically a shift to center that beam. Basically it runs out in both the X and Y direction and then we'll report back to you what the movement found as far as any off-center positioning goes, and you can adjust that and reset the origin to be centered. It's a nice feature in the software, which I'll kind of touch on as well. Now with our 1D Phantom, you can see here, basically we have two sizes of water Phantom. It's got 3-point leveling as well, so you can always be accurate with your depth measurements. We got a full function pendant with the 1D Phantom as well. It works with the software independent with both our Max 4000 or our Supermax electrometer. And it also will, with the Max or Max 4000 or Supermax, will also work with our software. So the ion chambers that we include with our system are our X-Rad and A28 scanning chambers. Are 0.125 cc volume, a spherical collecting volume. So it's nice. So if you're in both cross-plane and in-plane measurements, there's no issues there. You know, you're going to get similar readings on both directions. Excuse me. And then we also include a whole host of detectors available as well. We've got our different ion chambers, anywhere from our our 0.007 A16 up to our 0.6 cc farmer chambers, and then we also have a whole host of spherical chambers as well. The nice thing about our X-Rad detectors, it's all a homogeneous makeup. The collector guard and the shell are all C552 conductive plastic, so there's no high Z materials in there. There's no graphite coatings or graphite thimbles that become brittle with radiation. They're very robust, and that robustness leads us to offer a 5-year ion chamber warranty standard, with the ability to very inexpensively extend that out to 10 years as well. So we've got a long history with ion chambers as well. So we've been producing an X-Rad, and I've been producing ion chambers for beyond 40 years now. So it's easily one of the most respected chambers available in the market. So now kind of jump into the software, and I'll talk about that real quick. Like I said, I'm not going to do a deep dive into the software, but I'll give you an overview, and anybody that would like to get a deeper dive of the software, I'll be happy to work with you to set up a private personalized demo for you or for your group in your clinic. But as far as the software goes, it's a very easy interface. It's easy left to right, top to bottom navigation, like anyone who has ever used a Windows type environment is used to. It's again, like I mentioned, fully integrated for not only our DoseView 3D but also our DoseView 1D. We like to say there's no hidden features. Everything is kind of at your fingertips. You don't have to go digging for different functionalities and capabilities within the software. It's basically, it's 3 tabs across the top, and you do your setup, your measure, and your analyze all at your fingertips. I've got very intuitive menus for scan queue setup, that measurement and analysis, copy and paste functionalities, just to make your life easier as far as setting up your scan queues and what have you. So that being said, I'm going to jump into the software now and give you kind of a quick overview there to show you just how easy it is to set up. So basically, you've got your splash screen here. You can either choose to go into the 3D side or into the 1D side. Obviously, the 1D side is depth and point measurements only. I'm going to kind of key in on the DoseView 3D side, but then I'll kind of touch on the 1D side as well. But anyway, clicking on that to go right into it here, you've got your setup page here, where basically this is where you can set up your clinics themselves. You add your clinic, your locations, etc. Same with machines. Or click one, I've got my different machines here. My different machines are showing my energy, so it's pretty much easy setup there as well as you go. Detector wise, same thing. You can add a detector, and here's your different detectors here you can choose from. I've got a couple of A28s that are included with the system that are my reference and my scanning chambers. You can archive those if they go out of use, and just easily archive those. You can always unarchive things too. Say, for example, if you send something in for recalibration or repair, you can archive those and have them not on the list until they come back. Have you preferences? That's kind of where you set your delimiters for your CSV files. You choose your date and your time preferences, whether you want a 24-hour clock, how you want your dates to show up on the reporting, things like that. And then the scan queues, you have your different abilities to set your scan queues, and this is kind of where it goes pretty easy to set up and kind of guide you through things. For example, here you can see these are my four main categories for setting up a queue. That you can see here, they're not set. There's a few different things that need to be done before you're ready to move on to the next step. So for this one, just call it a test set. I already have one that's called test set, so I'll call it test set 2. So I've got that, and now you can see that marked as complete. And same thing with my energies. I can choose my energies accordingly. If I have, a new energy, I can add that. If I don't have that energy on this Linac, I said I can remove it easily. So I can go ahead and select my energies there, my field sizes. I've got, a few that I preset here, but if I want to do, say, a 5x5, easy enough to add that as well. And then it populates that there. I can do, if I don't want to do a 5x5, I can delete that as well, but I can choose maybe, for this set, I'll do just a 10x10. And you can see they're all starting to mark complete. My scan types, I want to do cross plane, I want to do in plane, gives you maybe some depth, it gives you the ability to do diagonals, you can do half scans as well, and the positive and negative cross plane and in plane. So I can choose those accordingly depending on what I want to do. I'm doing very, very large fields, 40 by 40 and beyond. You can do a half scan and stitch those together very easily with the software as well. Choose my depths. I want to do one, say, at Dmax and maybe 10. My CAX offsets, if I want to go off axis, I can certainly do that. I can choose, positive or negative. I want to go, 10 centimeters off. I can do that. Similarly, I can delete that and just stay on the center line and just do the central axis. And then finally, you have scan mode here. And this gives you a couple options for measurement of the 3D. You can either do a step measurement or you can do continuous. If I do step, it'll obviously be resolution in millimeters. If I do continuous, it changes to millimeters per second, and you can change your scan speed accordingly. I can do multiple or single zones, and that meaning if I want to do just a single resolution all the way across, for this one, it's going to be 15 millimeters all the way across. If I want to do multiple zones, I can do that. So if I want some higher resolution in the penumbra region, I can do that. So here I have in the green and the blue areas, I've got it set for doing 15 in the tail and in the flat region, but in the penumbra regions, I'm doing a high resolution at 5 millimeters per second. I can easily change that accordingly. If I want to do maybe 6, I can do that, and it'll automatically change that for you there. I can change my my zone sizes as well for my penumbra region and my my outer and my inner regions. I can choose my overscan either as a percentage of full with half max, or I can do a centimeter distance as well, and that's selectable there. So once I have those all set, I can go ahead and I can save my set, and you'll see that will put it right here at the bottom. So there's my my test set. As far as measuring goes, I'm ready to go to measure now. Once I have my my setup done. One thing I didn't mention in my my scan queues is that if I select one, I can go ahead and I can copy that. And you'll see now I have a copy of that. I can go ahead and I can then edit that if I wanted to do any editing to that. I wanted maybe to make these 20 by 20 accordingly. I can do that. So I can, and then I can save that, rename it as a 20 by 20 set, something like that. You have that functionality and capability as well. So, and you can do batch as well. So if I wanted to change change them all at once to 30 by 30, it'll do it all at once too. So you just select them all, and you can go in and maybe change that and adjust those accordingly. So it gives you nice copy and edit functions as well. Now moving on to the measure, this is where you kind of set up your hardware. It's kind of the same thing. You say anything that's gray needs to be addressed. So here Nice feature here is I've got there's a built-in demo capability. So even offline, disconnected from the hardware, I can go in and I can kind of play around and practice. Again, since you're not using it on an annual basis, might be something, or a regular basis, I should say. It might be something that you want to kind of just quickly refamiliarize yourself with it. So I can go ahead and I can, you know, virtually connect to a demo unit. So I can connect there and then I can initialize it. You'll see now that that turns as ready. And then my detectors, I can set those accordingly. I've got my whole host of different detectors here. I'm set up now with my A28s scanning. I can choose not to use the reference detector if I want. Set my electrometer. I can turn my bias on. So I maybe want to do 300, my field and my reference. I can zero it from here. Here's my position, and this is where you would do that locate beam center. You pop that on, and you can do it in both in plane and cross planes. I can go a specific depth. I can go ahead and click locate beam center. It will run through, move the chamber with the beam on to the 50% lines, and then report back any cross plane or in plane shift here that's required for your locate beam center. So let me close that. But now I've got this all set, and then I can go ahead and I can go to my actual measure queue now. I can load a queue, and I'm just going to load up my my demo set here that I. And you can see basically it's 5 scans. It's got 2 cross plane, 2 in plane, and 1 depth. You can go ahead and I can zero from here. I can normalize. So I want to normalize here. I want to actually go back to 0. That was because I quit out of the fine beam center. But I can go to that position. Then I can choose my depth, 1.5 centimeters for my Dmax. Normalize it. I'm normalized, and now I can go ahead and I can start my scans. And you'll see here they've got a green bar for your active scan as well as a percentage of progress. And those will scan. As those are scanning, I can jump into my analyze, and if I wanted to load up some scans, I can just let me grab a few different scans. These are all similar scans, with the exception of one. So I can go ahead and bring those up. And here's my scans, and basically, let me turn off my reference scans first. But here's your report of your scans here. We've got the scan IDs and all the parameters of those specific scans. I can open up my metrics, and here's all my metrics for those. You know, my full width half max, my beam center, my edge to edge configuration, where my number widths are, my central axis, where how that's measured. My max position, my Dmax, et cetera, flatness, symmetry. So it gives you those. It gives you a number of different filters as well. I've got a couple of different smoothing filters, Gaussian and a boxcar. I've got point edit, so I can edit individual points. A few different normalizations. I've got normalized to a specific value. I've got normalized at center. I've got the ability to center the scan. I've got the ability to do an average symmetric. I can mirror them, positive to negative and negative to positive. I can flip it 180, and I can also shift it if I need be. So some of the nice features there. One nice thing too is the ability now to do some additional scan comparisons. I've set one of these as a reference, and that's the red scan. Excuse me. And you'll see here now the metrics have 2 sets of reporting. The first set is the scan itself. The second set here shows you compared to that reference, and the 2 asterisks here means this is my reference scan. That ding just means that our scans are done. So we've got that the demo scans are complete. That just kind of an indicator that you'll get that if you have to change field size or change energies or anything needs to be changed in your scan queue, it'll notify you there. But jumping back to the analyze, You also, like I said, you can look at the metrics, compare, your reference, you select the reference scan that you want to use, and you can compare it to your the reference scan to your current scan. Gives you a gamma analysis graph here for the different scans. And then if you don't have a reference set for a specific scan, as in the case with 166 here, I don't have a reference, so that's noted by just dashes that there is no reference attached to that particular scan. So that gives you some of the comparison capabilities. As far as some of the other functionality we've got, you can merge your half scans here. If I've got some filters on, say I've done some smoothing or things like that, I can remove the last filter. I can clear all the filters. Your filters are shown down here as well. So there's your filters that are applied to these specific scans. I can look at my scan sets, and those are if I were to actually kind of bunch them together, which gives you the ability to kind of bring them together as a scan set, and that's done in the measure page right here. You can tag it as a scan set there. Export, I've got a number of different export capabilities. You can export it to any number of different treatment planning systems: Eclipse and Monaco, Electa's Aqua QA platform, Philips Pinnacle, Research, CyberKnife as well. So we've got all that functionality to import right into a treatment planning system. You can also export them as DoseView files. So if you have our DoseView software on another PC somewhere, you can export those as DoseView files and then bring them into another DoseView instance and open them up. CSV files as well. You can also produce PDD tables from your PDD curves. And then from those curves, you can also produce TPR, calculated TPR tables as well. So those are some of our export types there. And then import gives you the ability, again, like I said, if you have another instance of DoseView somewhere and you want to import DoseView scans, you can do that. We also have an import tool that's included with the system that allows you to bring in legacy scans, say from IBA or PTW. So if you want to import scans from those manufacturers, if you have an older system there, you can import those and analyze and compare those within DoseView as well. And then finally, reports. In the reports, we've got both a CSV type report of your data, and then we also can do isodose curve PDFs as well. So that's kind of a quick and dirty overview of our DoseView software on the 3D side. And really, the only difference on the 1D side is not only do we do depth measurements, depth scans, and PDDs, we also have single point measurements where you can do either like a timed or triggered measurement and choose the depth and duration, and then it will report those accordingly. And you can export the single point measurements right into a CSV file into Excel as well. So that's kind of the functionality on the 1D side. You can do your PDDs, but you can also do single point measurements too for your monthlies. So that, like I said, is kind of everything I've got for DoseView overview today. Check and see if there's any questions. I don't see any that showed up. Either I did a good enough job answering questions, or you're very shy and don't want to ask. So, but anyway, that's my overview there. Let me jump back into the PowerPoint real quick. And basically, just kind of a quick overview. A hardware Phantom summary, very structurally rigid. It gives you unparalleled repeatability and accuracy. Positional positions within 1.1 millimeter per axis. Very quick system setup, wireless functionality, fast acquisition electrometer with independent biases, and intuitive and versatile detector alignment system that's all included with the system. Software-wise, very fast queue setup for depth scans and profiles for 3D. for all energies and modalities. Conversion of depth scans to dose, which I didn't touch on, but you can obviously convert those right to dose within the software from the ion measurements. You can export those to PDD tables and calculated TPR tables. Numerous treatment planning systems. All those treatment planning systems are included. There's no additional charge for the ability to import into different treatment planning systems. You have in the depth measurements selectable force at Dmax, selectable force point at Dmax. So if you're not on a path that would give you a measurement at Dmax, it will automatically take a measurement at Dmax and then return to the original path. Those easy single point measurements on the 1D side as well. So this kind of, like I said, a quick overview. Went a little longer than I'd hoped to today, but hopefully you're still with me. And just wanted to, give you, that last summary, kind of showing you things, everything we talked about. It's kind of a redundant slide. I apologize about that. So, and as I mentioned, in 3.2, we've got the scan comparison, which gives you a comparison back to a user-selected reference scans, as well as the gamma analysis. Also, the TPS and TPR table export to CyberKnife treatment planning systems, the isodose curve report generation. And then we also improve the sub-millimeter depth resolution for our depth scans as well. But that being said, I want to thank you for your time today. As I mentioned, this is a quick overview. If you want to go a little more in depth of see how the software works and talk a little bit more in depth on the systems themselves, feel free to contact sales@standardimaging.com. That'll be directed to either your domestic rep here in the States or your international regional distributor, and then they'll get in touch with me and we can set something up. Or you can contact me directly with questions. My email, again, Hugh Peterson, so it's hpeterson@standardimaging.com. If there's no questions, I will let you get back to your day, and I appreciate your time very much. If you do have any questions after the fact, please feel free to let us know. Thank you very much.